And I believe we are still going, and we're live. Okay, good. So, hi everyone. I'm super excited today because we have a guest speaker, Sapan Parikh, that will tell us more about stuff that happens when you think about products, not only code. So, not only about crafting better code, but also having a vision of a product and how can we still ship faster and still quality, because there is this untold myth that, hey, if you want to go fast, you need to sacrifice quality, and that might be a myth. And Sapan will tell us more. But from my part, I want also to welcome the software crafts people in India, the community that actually is driven right by Incubite, for which Sapan works. So hi folks from India. You are pretty far away, pretty late in your time zone. So thanks for the effort for joining us here. I will let the floor to Sapan, but I just want to point out that the questions, either put them in the chat or keep them for the end. And at the end, we will have enough debates to try to clarify all the points. So without further ado, Sapan, thank you very much for taking the time and effort to prepare for today. And yeah, the floor is yours.
Thanks a lot, Victor. Thanks a lot. As you said, I am one of the co-founder of Incubite, as well as our Software Craftspeople India community. Feel free to visit our website. We are always hiring. We are trying to hire even in Europe. And here are our handles. Feel free to follow us. But moving on, I think, Victor, if you could stop sharing the screen. Perfect. I think what we wanted to talk about, so you know what, we are a perfect. Let's see. We are at the Microsoft Teams shop, so I'm trying to figure out how to make myself bigger on the video, so I can see myself. Yeah,
I just did it. I pinned you.
Oh, perfect. For yourself, it seems.
Oh, it doesn't happen for everyone.
But I see. No, I see it. I'm pinned now. So cool. Thanks a lot. Thanks a lot. So I think first, Victor, thanks a lot for saying I had prepared a start of this talk, but then you mentioned something about coding, and that reminds me of this wonderful book called Software Engineering at Google. And it has like the very first 1 or 2 chapters that talks about the fact that what does it mean when you say you're developing, or what software engineering means. And is software like programming same as software development or software engineering or not? And I think that's where, and you put it very well, that how the activity of just coding is quite different than doing the actual software development, right? And that being said, I think that's what the today's talk is about. We're going to talk about how to launch your software faster. And there's no real shortcut. So there's really no way where you can just do something like this and launch your software faster. But what we are going to talk about is that most companies believe that moving fast means we need to code fast. So like almost like hands on keyboard is what we are kind of measuring, and not the other things, right? And the common theme is that, hey, it's okay, we'll throw the bad work later and then do the good work. But it never happens, right? I think the reality is very different. You never throw something out. You call it experimentation, you call it low fidelity, you call it, no matter what you call it, once you start coding, the code you wrote someday stays there for a long amount of time, right? I'm sure you've heard about COBOL code, which has been living there in different servers, right? So it stays there. Nobody's out there rebuilding it. And we talk about going fast, but what about we're going fast today when we are starting a project or a new business, or a small team is starting something new. What about moving fast tomorrow, next week, a month later, 3 months later, so a quarter or a year later? Can you keep moving fast? That's another question that we want to answer. And what can we do to get there, right? And what is the what do you say? What is the definition of moving fast, right? And I think that's where I want to talk about the paradox of speed, right? A lot of time, and I think everyone may have heard this, that moving fast, to go fast, you have to go slow. And what does that mean? I'm going to talk about the definition of time itself. We as software developers have gotten the definition of time quite wrong. We think that spending time over here, this is mirrored mode. Okay. So we think that spending time over here is moving fast. So I'm developing. And if I do things faster over there, that's fast. And then everything else, I kind of do it later or not do it or kind of haphazardly do it. And this is what happens. If you are developing something and if you were diligent at the time of development, if you find a bug on this area right here, right? If you found a bug right there, you can actually fix it right away. You can fix it. You were doing, let's say, compilation error. At the time of development, something failed, you fixed it. Just imagine an error or a bug. Now it's not an error, it's a bug that goes all the way to the build stage. Builds are known. Some places it takes builds minutes, hours. If you're working at one of those companies where builds are manual, it may take actually a couple of days where a person makes a build, right? And the bug that actually you let slip to the build through the build, now it's going to take you way more time to fix it. And same if it goes to QA, companies are known to have QA cycles of like months. So if a QA finds a bug, you fix it and they test it again, now you're going to spend a month fixing it. And production is the worst. Production is the worst right here, right? Why? Because in worst case scenarios, I've seen companies which has yearly release systems, right? So they release a product once a year. And you won't believe it, actually, we are doing this survey. So every time when we interview a person, we actually ask them about their release cycles. And it's surprising how many people actually say that it's from a quarter to a year. So there are companies out there who are not releasing that software for more than, right? So just imagine if now you were to find a bug when you're in production already, what happens? You are finding a bug, you're fixing it, and it may take you 3 months to get that bug fixed to your users, right? And that means you have unhappy customers, or you're running around always doing hot fixes. And that brings me to the next point, which is and the point that I was trying to make is very nicely kind of depicted over here. That when we are working, when we start, or whenever we are working, we should do what's in the first column right over here. We should work on every different way or every different kinds of work, right? We may be enhancing capabilities, we may be managing complexities, unplanned work, innovation, all of that. If we don't do this, a lot of companies, and this is the current definition of moving fast, a lot of unplanned work and add new capabilities. Just keep doing that over and over again. And because a lot of people are doing what's in the second column, this happens with them. In a 6 months or a year's time, they're doing lots and lots of unplanned work. They are most of the time managing complexity. And then there's just this little sliver, just a little bit of time that they can give to enhancing existing capabilities. This not only ends up in unhappy customers, it ends up in unhappy teams, unhappy management, unhappy business. There's like total havoc, right? Nobody likes to be in this situation, the last third one, right? So that's what we're going to talk. And while we do this, I think we talked about the definition of time. We talked about seeing ahead and trying to experiment and do all different spectrum of work. But at the same time, we want to talk about staying lean also, right? So sometimes you kind of introduce a process, you call it an agile process. And what you can do is you can Google a Jira kind of this is called Jira's workflow, right? I just Google and this is an image. I'm pretty sure this company may be calling themselves agile company, but look at the number of steps which are there for something to get done. So here on the top, the gray dot where you see it, I think that's where you create an issue when it is open, and look at the number of transitions that one issue may go through. So while we want to introduce a certain processes or certain way of working, we are not in any way promoting working like that screenshot, right? Very complex. What we are trying to do is this entire philosophy comes from Toyota's lean management production system, right? Where you think of an assembly line where software is being produced and you're continuously kind of QAing and trying to fail fast as much as possible. That being said, I think we're going to move to different things that we're going to introduce today. What I'm planning to do is we're going to talk about build, deploy, and monitoring our systems. And I'm going to do a little bit of code demo. I'll walk them through, but this discussion is not really about lines of code. So I may actually use templates. I may get things in there just to show how or what should happen. The idea of this talk is to start a journey. This talk doesn't really, at the end, doesn't give you everything that you need. It rather gives you how, like, a framework in terms of how to work or what you should do when you're launching a product, or you're launching a new project inside your existing organization, right? So while we will talk about these things, you may go see me going a little bit faster. Victor, if you feel, please stop me and ask me a question if you feel that I went so fast over something. And I'm 100% sure, actually, that if you have a question because of speed, then everyone has a question. They're just not asking. So, right? So feel free to interrupt me and ask me a question if it's a little bit too fast. But as I said, the goal is not really go through every line of code. I'm going to take something very simple, but talk about the philosophy of it. That being said, I think the first thing is these fonts were supposed to be bigger, but anyways, what we do is, let's talk about the very first step of feedback, right? Outside of compilation error. Compilation error is way of feedback. You're getting to know right there and then that something's not working and you need to fix it. Outside of compilation error, the next step is how many tests can you write? We do outside in TDD. The reason is that we want to test different levels of things. The first circle over here says client, the second one says controller, and the third one says service. These are the typical components of how our layered architecture looks like, right? So a client is something like a browser or Postman or curl that's making HTTP request to your controller, that makes a request to your services. And one of the reasons that we work like this is that the companies who want to move fast, if they try to do this later, they may never get to it, which means if they say that, hey, I'll write these tests later, it may never happen. So at Incubite, we're always doing outside in TDD, right? So if we pick a project and if we are running it, then it's always using outside in TDD. So what I'm going to do is I'm going to get out of presentation mode, share my screen. And look at this simple project. Really, I have used Micronaut framework, which has something called Micronaut launcher. You can go there, you can launch, you can select multiple technologies, and it will create like a simple example applications on the fly for you. This is a very simple controller. Anyone who has worked with MVC framework, you usually have a URL. When you call it, it can call an endpoint, and you can say what it returns. So this is pretty much out of the box. When you create a Micronaut project, this is what it comes with, right? At this time, you may actually share your code on something like GitHub, right? Now, this is one of the biggest problems. As you start working with your project, a lot of people start using a system like GitHub as a glorified file sharing system. It could have been Dropbox or Google Drive, right? And again, I'm not sure how many of you, but to a degree that we have actually received zip files inside GitHub so that I can unzip and see code, which is inside the zip file, right? So based on how people are using it, I think a lot of people may be just using it to store as a storage system, maybe with the added benefit of being able to version your files, right? But any version control system lately has way more functionality. Each one of them has something like workflows or pipelines where you can not only just store your code, but do much more. So we're going to kind of talk about those steps as well. But we talked about writing test cases, right? And when you create a Micronaut application, it comes with this kind of like a simple test. What I'm going to do is I'm going to use one of the frameworks, one of the live template that I created for this talk. And I'm going to go ahead and inject a HTTP client at this level. So my test case is micronaut test. I can simply inject a client that can make a call to this endpoint. And I have written a test case over here. I'm going to go ahead and make this assert J. And now I have a very simple endpoint that's saying, hey, if I call this endpoint with year 4000, then it should say it is true. Now, what is the reason why we are doing two levels of testing. With an integration test, we're actually testing your network detail. And I'm not saying network detail, but integration detail, how you're going to go there and how you're going to get the data. But what you are also missing is a unit test now, because what this is saying is, this is good, right? It's telling us that, hey, no page found, which means there's no, this is a typical HTTP 404 error, right? It's telling you that, hey, I went to the endpoint, there's nothing over there. Now I want to go ahead and add something in the controller or create a new controller, but I'm not going to do that, because if you're doing outside in TDD, you tested your integration test over here, but now you need to start doing unit testing. In order to do unit test, or in order to write your new controller, I'm going to go ahead and create a controller called your controller, let's say. And I'm sorry for not specifying the problem statement. This is really just a simple leap year kata, but over a controller. So I'm going to my endpoint, I'm going to send a number, and then the endpoint should return the, hey, this is a leap year or not, right? So I'm going to say your controller should. We have a habit of using should as a word at the end of the class that we are going to test. So of course, we are going to test your controller over here. And then, not wasting time again, feel free to stop me, but I'm going to go ahead and kind of simply inject this code over here. We are writing a simple test that says should return leap. I should not even write should over here. But what we are saying is that your controller should return leap if year is divisible by 400. So leap should be true. There is no year controller. If I were typing code at this point of time, I would have just stopped at this point. And I would have said, hey, why don't we go ahead and create a class in my production packages, which is called year controller, right? So here I'm just doing a simple TDD demo. I'm not going to spend a lot of time talking about this. Now we're just almost done. I'm going to create the method. I really love this fact. To kind of create a like configure the automatically generated function so that it has this one line of unsupported operations. So if I go back to if I run, let me just go ahead and run all the test cases now. If I go ahead and run all my test cases, now it constantly tells me where do I need to focus, right? If I had multiple of these in a constructor maybe, and over here, I know where I have to go and what I have to fix. I'll come over here. I'm going to hard code this right now because there's just one test case. Nothing else has to happen here. Response here is equal to new year. I really don't need to do anything here. And now I kept some of the pojos in place because really this is not about the TDD part that we are doing. The reason I kept the pojo, we want to save time over here. So response here is a very simple pojo that I've already created. I'm going to run my test cases again. And there we go. So now we know that, hey, my logic is working. That's amazing, right? But what's not working is still our server, our endpoint is not working. Our network detail or integration detail is not working. And that's exactly what we want to know. This is the level of feedback that we want. First, we got the level of feedback inside the JVM that, hey, this logic seems to be working. That's cool. Let's move on. And what's not working is now our integration test. And I know why it is not working, right? Because this class is still just a simple class. It doesn't really say that it's a controller. So we have to tell our system that, hey, this is a controller. We should be able to go and kind of talk to it on this endpoint. And it's going to have one get method, which will take the year as a URI parameter, right? So here we are, and let's see if it works or not. And it does, perfect. So now what I'm going to do is this kind of signifies, right, that we do this multiple times. Our integration test is there. We don't do a lot of kind of changes. I mean, we don't, unless we really need, we are in a habit, or we are slowly starting a habit that not to write all the scenario in the integration test. It actually is testing the network layer. If we wanted like network layer behavior over here, which means if I send -1 and the response, HTTP response should be 500, I would write a test case for over here. But I would not write test case for 4000, 8000, 1996. All of those test cases will go right over here. Oops, right over here. So I have created those test cases. We have two options over here. Either, let me go ahead, and what I'm going to do is just walk through as opposed to typing. So let's see. Not the best code I have written, but it's a simple leap year calculator sort of a thing. We have a few test cases right over here. So these are the three test cases, one for 4000, 1800, and 2000, but 2016. We have our integration test. I'm going to go ahead and run that now. And it's working. So I think what I wanted to indicate was that one level of discipline that you can bring in is by working in a practice or discipline like this, where you're writing integration tests and tests together. It worked on my machine, but hey, works on my machine is considered a big joke, right? So working on my machine is not important. It has to work everywhere else. So what I did was, as I moved from one branch to the other, this new branch had a Git workflow, right? Again, be it GitHub, be it Bitbucket, all of them. And actually, I like some of the source code management systems have groovy pipelines. So I could literally write code. Unless you really love YAML, here it is. Kind of indenting those, right? So we have those over here. And really all I have done, it has few steps. Mainly it is caching stuff. But the most important step is, oops, do you see the word build right here? Right? So what we are doing is, and I think even using a build system like Gradle is a good decision in itself, right? Be it Gradle, Maven, NPM, the idea is that it comes with its own wrapper. So now when we push it on the CI/CD pipeline, right, where we have Docker image, it will download your Gradle W wrapper and run it, and then it will publish the test cases as well. So while we were doing this, let me go ahead and change something so that I can push this. Test cases are working, and I'm going to go ahead and push it. Right, so here we go. Now, as we push it, I think what we wanted to really see was this, that, hey, is our actions, does it actually start a build? Does it start running your test cases? Does it publish the results? So in a way, what you want to do is you want to start using your source control management system, not just as a storage system, but also a gatekeeper. Now, this is something where you can fail fast. You want to fail fast. And I think that reminds me of a story that we can talk about a little bit later. But I think this is a good time check and a good break. I mean, if anyone has any questions, or especially Victor, do you think we're going all right? Should we keep moving on? Any questions so far?
No, it's cool. I see you're using Micronauts. So interesting. Okay.
Yeah.
Quite nice over there.
Yeah, I love it.
I also love the should convention with the naming, but I found to kind of freak out some newcomers to the team. They are having a reflex to search for the test suffix. But yeah, this can be learned
Yes.
easy, right?
Uh,
And yeah,
and
this is
actually, thank you. I think our next topic about Sonar Cube is going to kind of this is the first Sonar Cube's first error is that it's a test. It should end with a certain regular expression, and it's not should, right? So it's one of the errors that you get when you're using Sonar. Um, and that's a good transition, right? So thanks a lot for saying this, Victor. What we talked about right now is tests. Then we talked about putting them on our build system. Then we executed them in our build system. Then we see if it is, hey, is it going to publish the results or not? We'll see if, yep, here we go. And we have the results. We have 5 tests, 0 are failing, everything's passing. So that's cool, right? So now this would have failed if test cases were failing like this one, right? Or this one. So we kind of created a quality gate, but really, is that quality gate enough? Do you really think that if I say this is the behavior, and then I say, okay, I'm writing code to kind of fulfill that behavior, then that means the code quality or maintainability or other aspects of the software are taken care of? Not necessarily true, right? So I'm going to go ahead and what I'll do is I'll switch to the next step. And I have intentionally gone ahead and added some bad code over here, right? Now, if you look at this code, something's wrong with my tests over here, maybe not. Well, if you look at this code over here, and let me try see running my test cases. They seem to be working. So did my test cases stop crappy code from going into my source control? No, it did not. And you need something to be there, right? So what I'll do is, while we talk about it, I'm going to go ahead and kind of...
I want to add the thing. If people are so disciplined as to use outside the TDD, the likelihood...
They will not do this.
Exactly, never, ever. I would meet someone doing writing. So you have had a very strong, let's say, demand to TDD outside in TDD that already raised the bar.
That's it. Actually, you won't believe it. One thing that I said was that when you're growing, and it's somewhere that will come in the conclusion, that what you do when you are growing is hire a lot of people. And a lot of problems actually start as you hire people. It's not necessarily 3 people who started the company. It's the 30 that follows. And that's when you need all these system in there, right? And see, this also I talk about a lot that, you know, in the world of software, we say it depends. And it depends is an answer that can only come if you're extremely smart. It's not actually a getaway answer that, hey, it depends. If it depends has to follow with a good answer. So a lot of time you have to introduce these frameworks for these other newer people who will take some time to get used to it. And then you're all set. You're right. You know, so I think that, anyways, moving on. So we have this issue over here. I'm going to, let me first quickly see if I have what I need. Anyway, so go ahead.
Lint was
Just telling me not to do it. Yeah, telling me not to do it. Yeah, but thanks a lot, Victor. Yeah, I think that's even faster feedback. But I wanted to go ahead and talk about this as we. So what I did using my macro. Let me go ahead and hide this area. We know, right? We already created a build step, but I changed it to build and scan. What I want to do is, hey, There's some secrets over here which are coming from GitHub. It kind of connects it with the project on SonarQube. And then we have some of the scanning settings. So it kind of scans our code right over somewhere right over. Interesting. I hope it does what it does. Yeah, right here. So we have our build, and right after the build, it runs the Sonar, and then it kind of sends it to the Sonar server. Now, for the people who do not know what it is, I'm trying to move this view from here to on the side. Anyway, so for the people who do not know, Sonar is a well-known static code analysis system, right? And what you're doing is you want other issues to be highlighted when you're writing code, which are outside of your tests that you wrote yourself, right? So I think this is like conflict of interest. You're checking your own books. Let's say if you're doing accounting, so you're also having like third eye, having your books double checked, and that's what we are trying to do over here. And what is the reason that we do something like this, right? So this is where shifting quality to the left comes into the picture, right? You want your scans and quality issues to be caught as soon as possible. And this comes again from Toyota's lean production system, where you would imagine sort of a assembly line where a car is coming and being built. And imagine before Toyota, there were these other companies which were building cars as well, but they would test it at the end when the car is ready, right? In like a garage. And when they test it, if something's wrong, the car stays there. Then they figure out why it happened. It takes them so much time. So this is a lot like the wrong definition of time that we talk about. But when Toyota came, what they did was the person who's working on the assembly line would actually test work of the previous person who was working as well. So while this is happening, if that person saw an issue, they would stop the assembly line. Then they would say, hey, a car, like a part came over here, doesn't meet the quality, what's wrong? So I think failing fast, once again, we want to do the exact same thing over here. Think of the assembly line as where our code is flowing from being written on our IDE all the way to being released, right? And this is one quality gate, so to speak, that we have, right? And actually Sonar calls it a quality gate. Let me show you, and it's adding it over here, but I have struts also open. Here it is, right? So I have, what I did is struts seems to be one of the open source project which is being scanned over here, and it shows all the different bugs. It has some 417 issues. You see all of those over here, right? So you can see all your issues over here. Now let's see if actually, oops, and it failed. Let's hope that it failed for the reasons that we thought of. And yep, see, it says it failed. Why? Because there is a bug. Let's see what bug did we end up introducing. There's something with the equal sign over here. And that's why, so that's what we wanted, right? We wanted things to fail at some point of time and not when there's a real issue that the production, that you find in production. Victor, you seem to have a comment over here. Do you have anything?
You know what, I would like to add something on this. Sonar is the most important factor that teaches people about decent coding practices and clean code today, besides code reviews. But it's something you really must have in any project. Without Sonar, you can't survive. You are automating the learning of clean code, basically.
Exactly. Actually, and thanks a lot for bringing that, because I really believe, Victor, that based on which kind of age of project, like are you a new gen software developer or someone who has worked on 5, 10 or 15 years old code, right? I have seen that it's every company, you can look at the age of it and pretty much predict how their pipeline is going to look like. So Sonar today has become part and parcel of the how everyone works. But you look at source code or kind of release pipelines of 10-year-old source code or 5-year-old source code. A lot of them don't have Sonar. Still, those companies are still working as if they were frozen in time. So I think you need deliberate effort to move forward. And that reminds me one more thing that I had read in Software Craftsperson by Sandro, right? And it says 1 year of experience 10 times is not 10 years of experience. There's just 1 year of experience 10 times. So a lot of them still do it. So some of these things may be missing. You're right, in newer projects, newer places, newer products, it's almost a de facto standard, right? Now I see that we have, this is 10:06, so let's see how much time we have. But we did see, hey, we added a issue and we kind of found it before it kind of goes in production. I'm gonna go ahead and, so what we saw over here so far, we are talking about failing fast. We failed, we created a build, we automated the build, then we wrote test cases. Test cases were being executed locally. Now they were being executed on GitHub. We're trying to create as many quality gates as possible. Now there's a quality gate at Sonar. So that's breaking. So we kind of now have a third eye. And I don't know what happens after GPT-3 starts scanning your code as well, right? And so future is bright on that side. And so that happened. So we got a third person or third virtual person looking into our code and giving us code review tips. And now what's the next step, right? So the next step would be, why not deploy it, right? So I'm gonna go ahead and switch to step 3. It's the same code. On the way also somewhere I kind of refactored it a little bit. And I'm going to go ahead and change the deployment pipeline once again. And it had all the Sonar related and test related things earlier, but now we added few more features. What do you want to do? So a build pipeline that does not create artifacts at the end of the build is quite useless, right? You want to be able to say, hey, this is my version 1, 2, 3, 4. These are my artifacts over here. We are creating Docker images. So here is our Docker. What we're doing is we're trying to log in to Docker. Then we're trying to do Docker push. We are using a Gradle plugin to do a Docker push. So it gets pushed over there. Then we sign into Azure CLI. And after that, we kind of use Azure command to push the entire image, right? Now I'm going to go ahead and why not just push this while it kind of deploys, right? So why do this right now? I don't know if you have seen this. A lot of companies are not all. So have you seen like banks are software companies nowadays, right? Banks or a taxi service is a software company nowadays, right? And when they're working, companies which are not software development, totally product companies, a lot of time they do all of it, but the last extra mile, last connectivity may be missing, right? And I specifically ended up saying I don't hold anything against banks. But I know a trading software. I don't know, Victor, you or anyone in the right the audience has heard about Knights Capital.
They are not known for very good quality. Yes.
So there was a company called Knights Capital who would do high frequency trading on Wall Street, and it's known that they had like a couple of servers, let's say 10 or 5 servers, I don't know, and someone manually upgraded 4 servers and not 1. So 5th server was not upgraded. That file didn't drop in over there. The next day, one thing led to other, and I think it automatically traded around $1 billion or more than $1 billion worth of stock. At the end of the day, they made loss of $400+ million. They could never recover from the losses, and they were taken over by a rival. So a rival company kind of took that company over with the losses. So, and it seems very small, right? Hey, it's just this one file, configuration file. I'm just going to go ahead and change that, or I'm just going to change the database connection. We've seen so many times, some manual configuration doesn't happen, and this production system that's supposed to kind of connect to a production database connects to a test database or other way around, and things like those go wrong. And we are not talking about some made up story. These are real things. And they are not old stories. So I don't know if you heard about January 11th, right? Just a month back, a little bit about a month back, there were no flights flying in the United States. Again, someone tried to do a manual change in a file and something went wrong. And FAA's flight alerting system was not working for a couple of hours. So no flights in the States, right? So the real consequences of doing this. And sometimes we kind of should take that extra discipline and practice to make this sure as well. And this, I'm saying we do it from day one. So I think audience can go ahead and read something called walking skeleton, right? When we start with a walking skeleton and do everything rather than just thinking about the new features, and make that whole connectivity available for developers to work on. I commit something, I can see it on a server in a few minutes, right? That being said, let's have a look at what happened. Are we done with our build? We had pushed one with deployment, but let's assume that it will deploy. I'm quite confident. I've done it 3 times today, so it should deploy. And that being said, maybe we can move on a little bit, right? So now what I'm going to do is I'm going to just go to my main branch. And talk a little bit about this over here. So one of the biggest problem when people are working with business, so there's developers and what we call business, right? Or product analysts or project managers. They're continuously thinking of the value proposition, like, hey, get me a integration with Okta, let's say, or that's actually the most technical thing that one can say from the business side, but more like create a dashboard to do something or make a screen where I can enter data. When you're saying this, these are all functional requirements. What they're not talking about is non-functional requirements, right? What are non-functional requirements? So things that they're not saying, but they're expecting. So they're expecting that when I click on the submit button, it should respond back in a second or so, right? When I get the sign-in screen, when I hit enter on my browser, I should be able to see that screen in a couple of seconds, correct? So those are my non-functional requirements. And there were times when developers only did kind of programming and nothing else. But after the DevOps culture set in, I think the teams started becoming more and more cross-functional. And because of that, these teams now have have roles like site reliability engineers, right? And they actually take this one step forward. They define something called SLOs, which are service level objectives. So they are not just thinking of my screen, whether it shows me the data or not, but they're also thinking, hey, if I am an API business, do I want this kind of SLO, service level objective, that 95% of my response time must be below 500 milliseconds? Or of all the HTTP calls I make, HTTP errors must be less than 1%, right? So these are some of the SLOs that SREs or the development teams, and they're so nice. Nowadays, performance testing, you don't have to do in different tools and JMeter. There's a very nice tool called K6 that we are using where you can write it in TypeScript, right? So we wrote like this small thing that I write over here. I'm going to make a small change over here. Let's see what happens. But what I'm doing is I took 10 minutes to create this test case that says, hey, create 10 virtual users, hit this URL so many times, and at 0.5, right? So what we want to do is we want to kind of keep hitting this URL, sleep 0.5, and there'll be 10, and you do it for 1 minute and 10 virtual users and sleep for 0.5 seconds between the requests, right? And while you are doing all of this, I want to make sure that my HTTP error rate remains less than 1%. And this is now what I could have actually done while we were talking. I could have deployed it. Right. What I did was I used a cloud version. So let's see how I did it, right? So I added a simple, again, one more workflow in my GitHub that simply says that, hey, this workflow should run after a completion of my previous workflow, which was my Java CI/CD, which is just making the build, tests. If everything works, then you move on and do this. This is simply saying that, hey, use the K6 plugin on success, and here is my JavaScript file that needs to be executed. And then I said it, let's push all my results to K6 cloud, right? So all my results are also now going to the K6 cloud. And this is the file. So that's about it. So we released something. So we now just imagine where we have gone, right? We were thinking just a few minutes back, hey, am I getting a compilation error and feedback or not? Now we are deploying something on the fly, then running a test case and saying, hey, are my SLOs meeting or not? And this I can quite confidently say that you can do it in first couple of days itself when you're starting a project. If you were modernizing a system, it may take you more time, but I think this is at least something that we should do. When you release the product, I think you owe it to the users that you check the performance, right? So you do that over here, and let's see if, I think it's going to take a couple of more minutes. It's running the test cases right here. What I can do is, as it is doing Docker push and deploying it, let me go ahead and show you a couple of older tests that I have executed with right and wrong URLs, right? And if you look at it, this dashboard can show you. And I love the fact about how these tools work, the fact that it has dashboards. You suddenly made it business friendly. You can show it to your vice president or a CEO and say, hey, look at our thresholds, right? Exactly. So here you go, 95%, more than 95% requests are under the given time, and there's less than 0.01, 1% requests are actually failing. So you can catch that. Or if there was an error, you can catch that. Hey, you just broke something. All your HTTP requests are failing, right? Happens. Sometimes you change the controller. This is another issue, right? You change a controller. This is a good one, actually. And this is something that you want to catch again sooner than later. What if I change something over here? It's in a string, right? All of the things will start failing. So here you go, catching it early, failing fast. And that leads me to our next thing. Do you really think that our job of getting feedback is only when you release something? No, right? So you want to constantly keep getting feedback, even when your users are using the system, even when you're asleep, most probably, right? So what do you do? In this case, we decided to use App Insights. Again, not promoting a tool over here. It's like New Relic or Elk Suite's APM or App Dynamics, right? So Azure has that. It was handy. We used it over here. And as soon as you do that, what you start getting is data inside the application as well. And let me explain you what we mean by inside the application, right? So there's always, when you use the cloud and when you use it right, this is my instance that is running and it's telling me about my CPU, it's telling me about the memory it's using, network. But what we call this is black box monitoring. Black box monitoring means it's just telling me that, hey, where's the CPU stand or where does the memory stand, right? It doesn't tell us anything about what's really happening. And I think that's when you use something like App Insights or Elk Suite, right? And we created, this is the default dashboard that we have. Let's see if our load tests are executing or not. Not yet. I think these are the older ones. Yep, 1 hour ago. So not yet, but if they were running, I think you'd see more kind of HTTP requests, server response time, all of this data you're getting over here. So the SLO that you had defined, you want to make sure that your service level objectives are not just meeting when you're testing, they should meet in production as well, right? So now you take time to create alerts over here, and then you start getting your SLO. So I think that a user shouldn't have to tell you that the service has degraded. You should figure it out before it actually degrades, right? So you figure it out, and you start fixing it even before your users know. And this is one way of doing it. So I think this is what I wanted to talk about, that this is an end-to-end, we want to kind of end-to-end feedback that we want to get. And right, so growing fast doesn't necessarily mean coding fast, but it's sustaining your pace of delivery, right? Beyond the first few months, you want to continuously do it and of course, this discussion is quite useless if you're writing a script that you're going to use 5 times and really through it, right? But if you're writing a software that's going to live longer and other people are going to use it, then I think you want to sustain your pace. You want to continuously keep giving your users new features and new things, right? So that happens. And Victor, here's my note bullet point that says, if you do this, onboarding new engineers will be much easier as well, because you have these quality gates, right, in there. Getting your features in your user's hand will be much faster as well. So if you think about it, we're talking about accelerate matrix right now. You're talking about reducing the lead time to delivery. You'll be able to write something and you'll be able to release it faster, right? You'll be able to fix issues much faster than before, right? Because your users may not be finding many of them, but if they're finding, your lead time is much shorter, so you'll be able to fix it and release it also faster. And this way, you'll be responding to your customers' needs much faster. So you're bound to have happier customers, and we can say it from our own Incubate's experience, Victor, that the kind of emails that we get is not the kind of emails that you would actually a software services company would get, right? So they see how fast we are moving when they're working with other software vendors who takes months for softwares to be released. And I think that's that. With that, I would like to conclude my talk, and we are just in time.
Yes, wow. Unlike me, you were in time. Very good. Very good. So basically, this last point, maybe this can get even more fine-grained, right? Like collecting internal metrics from
Yes.
like micrometer and stuff, like in
Yes,
code.
this is actually using micrometer. I haven't kind of jumped in here, but yes, it can. You can actually do integration. I'm not able to go in right now.
For example, monitor the response times of third-party APIs that you call, or monitor
Oh
the
yes,
iteration of the delicate method. Yeah.
yes, and SQL queries. So you could find out which queries are taking much more time than any other. So yes, and I love New Relic for that matter. New Relic is really amazing. The kind of detail that it can give for like at least Java code that we have seen is really good. And again, we didn't want to just talk about Java. You should do this no matter which technology you're using.
Very cool. Yes, Datadog, Dynatrace. There are many names here. One note here. There was someone in the chat asking about Sonar Lint, the plugin. Could you go back to code just a second? If you have that bad code around somewhere to show the guys, to show the folks.
Yes.
Because yeah, you can reduce the feedback loop even more if you
Even
have
shorter, yes.
shorter. Yeah. The tricky part is finding the branch or the code. There.
Yeah. And you can do Command Shift S, and right here you find Command Shift S, and all your
And
errors
if
are
you
right here.
change anything in that line and commit it, please do the folks a good. Change anything in there and try to commit again. Just try. Don't actually commit it. Sonar lint, right? Will kick in.
Yeah. So yes, it will. So let me right now just do a kind of let me.
Yeah, just anything. Commit.
Yeah. Well, so now it will even show like issues.
There. This one.
Yeah.
There you go.
Yeah.
And if you say, so basically they are warning you that you will be laughed at. That someone else will say, hey, what the heck? Exactly.
Yeah.
One last chance to do repent refactoring. Yes.
You're right. But let me also tell you, I mean, SonarLint can give you bad issues, like things that you shouldn't.
False positives. Yeah.
False positive, a lot of them. So you have to, it's a long journey. You have to kind of fine tune it based on your way of working as well a little bit. And then I think people should not use it. Any system is as good as how easily can you kind of circumvent or escape it. So I see, I don't know if you know this. So first of all, Sonar should not do it, but if you do int, I don't know, I is equal to 0, it may actually say, let me see, this is a magic. Actually, for 0, it may not say magic number.
Yes, I see. I saw it in my projects. Repeating a space, for example, between quotes in 3 or 7 places in a file will say, "Hey, constant." No.
Exactly.
No.
Um,
So always
uh,
use the judgment. Yeah.
no. So I'm saying this is people would do something like this 1987, right? And or even now I don't think so. You necessarily have to kind of let me just make it float, right? If a value of pi, it's so well known that I don't necessarily know if I want to use the word pi every time. And maybe I want to use the word 3.14. It's well-known value. But not only that, what people started doing, so I've seen something like this where you'd have number 198 and Sonar would kind of complain that, hey, 198 is a magic number. And they would like literally do 1,
98.
9,
Exactly.
8, and then
I see
store it and then use that variable, right? So
constant space equals space. Wow.
space, yes, exactly, right? So yeah,
That's
I
when
think
what happens if you blindly follow a tool. So always follow your judgment first, of course.
actually, and so that's where I was talking about. It depends answer, and that also I'm heavily influenced by Toyota's lean management system, right? Lean production system, and it talks about something called Shuhari. So it's like a framework. So when you come in, Shu is when you can follow something well. Ha is when you can master it, and Re is the final stage when you can redefine the rules. You can like literally change the rules. You can talk about the rules. You can have a debate about it. So that's how you kind of climb up the ladder. If you stayed always at the shoe, this is what you'll end up doing, which is you're not improving and you create a variable called 19. But this is the time when if you have become more mature, you may actually go to Sonar and disable that rule for that matter.
Oh, you imitate, you master, you challenge. And the same with clean code, the same with EDD, the same with everything. You first imitate until you master it, and then you start
Master,
thinking about
challenge.
the rules. Yes, there are some ideas in the chat more. When you talked about Sonar Cube on the pipeline, there were multiple. I mean, the discussion went about security vulnerability scanning tools like Sneak or like what was the key? Someone proposes another name, and these are also
Snake.
fun. Snake, yeah.
Right?
There was
Yes. We use that too. And it really sometimes depends on what kind of business you are in. So, right? A lot of people are actually creating a software that runs only inside a VPN, and sometimes they don't care as much. A lot of people are creating public APIs, and it has to be. I like even the open source version of Snake would go ahead and at least check your Docker files and see if there are any vulnerabilities or not. We do a lot of this. So we also use J dependency or something that shows all the CVEs, right? All the vulnerabilities which are not in the dependencies of your
also
and
IntelliJ
Snake.
shows this, right? IntelliJ recently several months ago, started showing vulnerabilities to our despair in our POM. Like, oh, it's all yellow. Yes.
Exactly.
It's
Exactly.
very.
So, yep. It monitors SQL query by default, or some interceptors are needed. So it is. Thanks a lot for asking that question. It's a little bit more involved, and as I kind of I did a lot of magic while switching from different screens, but let me see if I can. Yep. So what we did, and almost all the different technologies requires you to use some kind of a Java agent. And here is my Java agent. So this is where the magic is happening. You are on the, yeah, go ahead.
Yes, just pause for 2 seconds. Sorry. Someone asked if you need any kind of interceptors to monitor SQL queries. This is the one, right?
Yes, I think this Java, yes. So I'm assuming that when we say monitor the SQL queries, we're talking about App Insights or New Relic or any tool that you're using, right? You can, no matter which tool you're using, they are going to tell you to add a Java agent. So I think after JDK 1.4 or 1.6, they came up with this runtime bytecode editing, right? So you could on the fly add a jar file like this, which edits the bytecode on the fly, and based on that, you get the data. So yes, this is how we have done it. Most other cases also, you have to attach a Java agent as you run your process, and this. Let's see if we have a. What it does is because of that, it creates the entry point of the Docker file now has a Java agent when you start your application. So here is the Java agent, and that starts then capturing and sending data to Azure App Insights in this case. Or a JDBC proxy without an agent, yeah.
Basically, this Java agent spices up your code to measure known parts that can cause performance issues like JDBC, networking, everything.
Yes. Long time back, we used to actually had to instrument our code. I don't know if you knew, there's something called instrumentation. So you'd actually create a bytecode, and then it'll be a two-step process. Now you do it on the fly.
Cool. Very cool discussion in it. I hope it opens our eyes more about the whole pipeline. I mean, they're trying to, and I love this talk because the focus of the event on my community were until this one most on code and code only and refactoring, and in the end that's where the magic starts to happen. But soon you realize that you're actually solving a problem, not just code, not just work for code for food, and you start solving solutions, not just shipping code. Interesting. Very well. Very good perspective you brought over here. Nice and nice overview of all the moving parts involved in all this journey.
Thanks a lot, Victor. And I think this is also an effort to kind of propose that a lot of developers kind of think, not my job. Right? I think so. It is our job, right? Being a good software craftsperson means doing this end to end.
You want to get fired by ChatGPT, so
yeah. So
more on the problem than
setting up the walking skeleton. I think that's the most fun part for me, like setting up all those integrations at the beginning and seeing the long-term benefits. That's just like gold.
Yeah. Thanks a lot.
Folks, thank you so much for the effort. Nice effect at the beginning. I was, wow, he did those videos. That video has slides on it. What was that? Amazing job. Thank you for all the effort and all the preparation. You worked a lot hard for this. And thank you for the time. It's what, 10:30? Or it's late. Too late.
Thank you so much, Victor. Right. Appreciate it. And we are going to launch our Incubates channel on YouTube. I hope people will find us on YouTube and follow us. Subscribe. Hit the subscribe button. Thank you.
All right. And you told me something about the plan to start staffing in Romania. Am I wrong?
Yes, we want to hire in Romania. I would really love for people to apply. Send us an email. My email is sapan@incubate.co. You can get in touch with us on Twitter, or just best way is go to our website and they'll find a careers web page, and there's an email address over there. Please shoot an email. We're trying to find
hiring. They are hiring.
Yes, hiring. I didn't create a slide for that. We are hiring. Thanks a lot. Really appreciate it.
Good. Thank you, folks. Thank you. Bye-bye.
Bye.
Thank you, everyone. Bye.